Hello guys, welcome back to Techies Tute. Now today let's see what is interface. So using the interface, object define their interaction with the outside world through the methods that they expose. Now what is the meaning of this statement is, if we want to communicate between the multiple objects and if we don't know what how to communicate, so in that case the interface will help us to just interact the different entities, and it binds a specific type of contract between those entities. So in that case we have to take a help of interface, and interface gives you certain rules, set of rules, and that we have to follow into our class. So let's see what is basically the interface and details about the interface in the next slide with an example. So before to go further, just we cover the theoretical part. So the next is methods form the object interface with the outside world. So interface basically contains the list of method prototypes, and that method prototypes we have to implement into our classes. So interface is not a class. So interface is a different entity. It is object entity, but it is not like a class. It is a similar to class, but it's not the same like a class. So writing an interface is a similar to writing a writing interface is similar to writing a class, but they are two different concepts. So interface and class is a different concept. In a class we have the implementation of methods and declaration of data members, but in interface only final and static variable declaration is allowed it, and only abstract method declaration is allowed. So that is the difference between the interface and class. So we can create object of class, but we cannot create object of interface because abstract things are available inside the interface. In a class, another difference, in a class it describes the attributes and behaviors of an object. That means we are providing the implementations into the methods, and interface contains only behaviors that class implements. That means in interface we are only declaring the methods, and that methods we have to implement inside the class. So this is the golden rule for the interface, that is the interface contains only behaviors that class have to implement it. So it is the we are putting a restrictions onto the class, that if we want to implement interface we have to follow the rules which is given by the interface. Now let's see the example. So for example, suppose the interface is available with the name bicycle. So basically what is a bicycle? So which entity we can say it is a bicycle? So we can say when it is a bicycle, suppose we can change the gear, suppose we can increase the speed, and suppose we can apply the brakes. So change gear, speed up, and apply the brakes, these are the behaviors. Okay, now it is a now if a particular entity or object follows these behaviors, then you can say it is a bicycle. Okay, so we design such a kind of one interface, and if we want to create our own bicycle, so we have to use this interface bicycle. Then and then only we can say now my bicycle is a standard bicycle because it is having an behavior change gear, speed up, and apply brakes. But this is only declaration. This is the just a prototype of the method, and that prototype we have to implement it. That means definition of this method we have to implement into the interface. Now let's see how to implement it. So how to declare interface with it is interface keyword, name of the interface, you can give it name according to your requirement, and the set of rule is defined here, curly bracket end. So it is interface. Now how to implement it we will see. Look here. Now class AC yummy bicycle, suppose this is my bicycle, and if I want to design my bicycle, so definitely I have to implement a bicycle interface, because then and then only my bicycle is becomes a standard bicycle according to the bicycle interface. So what is a bicycle interface? Bicycle interface having the three properties: change gear, speed up, and apply brakes. Okay, so change gear we have to override here, And what is the rule to override method overriding? So prerequisite for interface and abstract classes is method overriding. So we should know the what is method overriding. Now look at public void change gear. So method overriding prototype must be same. So it is same. It is having some integer value, that is what number of gear you want to change it, and the access specifier is wider or same, right? So it is a public, and in a year there is no any access specifier. So I want to clear here, if there is no access specifier mentioned inside the interface, in that case your method is by default having a public, and these methods are by default abstract. So here you write a public abstract or you don't write a public abstract, by default it is public abstract. So this is a rule only for interface. If in a class, if there is no any access specifier mentioned for a method, then it becomes a default scope, right? But in case of interface, it is a public and abstract. So now this method is a public and abstract. So here we have to override it using public. So we, at the time of overriding, there is no keyword used as abstract. So public void change gear and the value, and whatever the procedure you want to write it, gear is equal to new value. So this gear is changed. Okay. Now here same for the speed up. So we are again applying the @override annotation just to check at a compile time according to the super type. Method prototype is according to super type or not. And here integer increment speed, we are increasing the speed. Same for the apply breaks. So we are decrementing the speed. Okay, so this is the procedure. But ACME bicycle follows these rules, and these rules are given by which interface? That is a bicycle interface. If there is no any interface available for ACME bicycle, so there is no, we are putting a restriction on this class that we have to follow change gear, speed up and apply brake behavior, right? We can only use a change gear, we can use only speed up. So it is not become a part of your standard bicycle structure, right? Bicycle, whatever the standard prototype is given for your bicycle, it is not according to that. So we have to stick to the some certain rules, and who given that rules, that is a bicycle. Okay, and other methods are the, like these print state, these methods are the optional methods. These methods may be related to your class, so it is okay, it is not a problem. But these rules we have to override. If whatever, how many methods are there? Change gear, speed up, apply brakes and print state. So out of 4 methods, 3 methods are coming from your bicycle, and that we are overridden into the our class. Look here, change gear, speed up and apply brakes. If any one method, I just make a comment on this here, comment, suppose speed up, I don't want to provide implementation for this, so compiler will give you the error. Okay, because interface contains a behavior that class must implement inside their body. Okay, so that means inside the class we have to override those methods which is given by the interface. So how many methods are available inside the bicycle? 3, and 3 must be available here with implementation, not only declaration. Okay, so this is your rule for the interface. If you forget to implement any one of the method, then it gives you error. Okay, let's see the demonstration on this. Let's declare an I1 interface, or I declare it my interface. Finish. And here I declare it void f1. So this is for demonstration purpose, void f2. Now look here, I write here public abstract, and this is without public abstract. By default it is public abstract, so just to differentiate between f1 and f2 I have written this. Now just I create another class so this is my class, and just here void f3, and this is the method of the same class. Okay, now I want to implement the my interface inside the class my class. So in inheritance we are using the extend keyword to just extend the class, but to implement the interface we are having the implements keyword. Okay, so implements is a keyword and then the name of my interface. So now look here, it gives me something error, right? And just read the error. Multiple marker at this point, my class must implement the inherited abstract method which is available inside the my interface f1, and just read here the type my class must implement inherited abstract method, that is a my interface f2 method. So we have to implement f1 as well as f2. So in Eclipse we are having an intelligence. Look here, add unimplemented method, and just click on that, just double click on that. Automatically you will get the methods at the rate override public void f1, automatically public access specifier added. Now look for the f1, here there is no any access specifier public and abstract, still automatically it is added public. Why? Because in interface by default methods are public and abstract. So you write here or you don't write it, both are same. Okay, and look here, the curly bracket start, curly bracket end, and here you have to write our code. So implementation is now available at the rate override for the f2, again the implementation is available. Is it okay? And now here for a testing purpose I only write a SOP statement, and here I just write it's inside the f1. Okay, and here I write inside the f2. Okay, and for f3 I write here inside the f3. And look here, these only two methods which is overridden, and this is the specific method available for the my class. Okay, and now look, I just go with the main method. So I create my test interface, and I want a main method, just finish it. Now look here, you have to create an object of my class, obj is equal to new my class. Is it okay? And here, can I call f1? Yes, I can call it. Can I call f2? Look, I can call it. And can I call f3? Yes, I can call it, because all three implementation is available inside this class. I just run the code, check it. Yes, inside f1, f2 and f3. Now it is okay. Now in an interface, suppose I try to create an object of interface. Now just check the error. So here my interface obj2 is equal to new my interface. Okay, oh sorry, so my interface. So in this way I cannot create an object because it gives me error, because look here, inside that interface there is no constructor available, right? You cannot write a constructor also, because here we are having an abstract entities. So like an abstract class you cannot create the object of abstract class. Similarly you cannot create object of interface. But okay, now here I can do like this, my interface is obj is equal to new my class. Is it okay? Now it is showing me error because when you do the upcasting you cannot give a call to f3, because in my interface you don't have an f3. So in upcasting only you can give a call to f1 and f2, because it is a runtime polymorphism, correct? So look at, when you are creating a reference of interface and you are storing the object of your class, so this is again an upcasting, correct? But in this case we don't have an object of my interface, because f1 and f2 only declarations are available, and obviously this is your runtime polymorphism, correct? Okay, and for f3 we don't have a reference into the my interface, and that's why here it is not applicable. And using this type of upcasting we can pass any type of object to this obj variable with respect to its interface. That means the class who implements my interface, only those objects we can store into the variable of my interface. Okay, so this is basically the useful concept of casting, and we can create a method where we want, and we can pass any type of object to this type of variable where my interface gets implemented. Okay, so now suppose if I don't want to write all these things, and I want to write the class implementation or my interface implementation of the methods, and I don't want to define a class separately. So inline implementation if you want to provide, so this one, another option is available, and this is known as a anonymous inner type. Okay, and how to do it? So you just create an object of my interface and you just click intelligence of this. So look the syntax. So it is a syntax similar like a class object. My interface obj is equal to new my interface, and here rounded bracket. Now from this statement you can just see, and you can say, sir, this is an call for the constructor of my interface, but I want to show you my interface. My interface is the interface and it is not having any type of constructor, so we cannot create object. So you will say, sir, it's object. It is not object. This is an object for the anonymous class. This is not an object for an my interface. Okay, this is an object, but it is an object of anonymous class, means this is an object for the class who don't have any name. So where is that class? Where is that class where we don't have any name? So that class is available here. Look, here curly bracket start and the curly bracket end. Okay, now that means look here. So this line looked like an object of the my interface, but it is not object of my interface. It is object of anonymous inner type. So it is an anonymous class. Which class? So here you have a here there is a class, so it's an anonymous class. Okay, so in an anonymous class, what they did, at the rate f2 override and at the rate f1 override, that means brackets, your body for the f1 and f2 is available. So it is a class, but this class don't have any name. That means you cannot create an object of this class explicitly, but already you created a obj, and directly at the time of object creation you provided the implementation of such a type of class. So this is the syntax for anonymous inner class. So in this way also you can implement the interface. Only the drawback of this, you cannot create object of anonymous class in a different way. So because when you create an object of my class, you can create n number of objects of my class separately, correct? But here you cannot create an object of this one, because here you have to write a body. So the you can say the reusability is not possible in this scenario, and in this scenario reuse of the code is possible. Okay, so here look, the same syntax is available, only the class name is available, but here we don't have any class name. The same thing is you can doing in a first example and second example, only the way to implement is different, and this is known as a anonymous inner class. Okay, but and then after that you can create a call an object is like f1, it is okay, and obj dot f2, right? But in f1 and f2 I have not written anything, correct? It is empty, it is empty body, so it will implement, but there is no output, so there is no output, right? So I will write a statement inside this, inside the f1, and this is using the anonymous class implementation, correct? And I write same thing, and this is f2, and here again I just use it. This is f1 and this is the class implementation, and now I run the code. Now look it, inside the f1 using the anonymous class implementation, inside the f2 using the anonymous. So here the spelling mistake is there. Okay, so I hope you understood the interface concept. So you write it, then if you have any doubt you can just make a comment in comment box. Okay, thank you.